Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 11 and Section 3, Areas of Polygons. Let's first look at special quadrilaterals. We have the rhombus, and I want you to name some properties of a rhombus, and also a kite. There are some special properties that go on here, and let's just talk about those. If we draw diagonals in a rhombus, then we know that they form a right angle. And since they form a right angle, then I have 4 right triangles in here. And if I look, the right triangle here and here are going to be, if I put this triangle together, that is congruent with this triangle here. If I look at the kite and draw a line right straight like that, and then draw another diagonal there, I also know that kites have a right angle there. Therefore, this top triangle here is going to be congruent with this bottom triangle down here. Finding the area of a rhombus is just a matter of finding the area of half of it and then just multiplying it times 2. So let's just take a look at what the areas are. The area of a rhombus or a kite is simply 1/2 the distance of the 2 diagonals. So in a rhombus, if I just take this distance of this of this diagonal, and I take the distance of this diagonal and multiply them together times 1/2, then I get the full area of the rhombus. And that's because if I just look at this triangle here, the base is D2. The height is going to be half of D1. So the area of the top triangle is 1/4 D1 times D2. When I add in the bottom area, then I get 2 of those. So I get 1/2 D1 times D2. In the kite, the same thing is happening. This top triangle is going to be a full D1 times half of D2. And if I use the triangle formula, I have 1/2 D1 times D2. Well, it's 1/2 times D1 times 1/2 D2. And that gives me 1/4 D1 D2. The total area is going to be the same for the rhombus and the kite. Computing the area then is fairly simple for this part A. You just multiply 8 times 6 times 1/2. The same thing with this kite. It's going to be 1/2 the height here and one diagonal and the other diagonal times 1/2. So I'll let you compute those. And we'll continue the discussion in part 2.